Hi, good morning to all. Today we have another interesting topic from the physical pharmaceutics, that is introduction to complexation and protein binding. So what do you mean by complexes, or what are complexes? See, A and B are the individual components. They react together to form complex C, and the property of complex C will vary from both A and B. So the properties of the complex will vary from the individual components A and B. So after completing this chapter, the reader or the student should be able to understand the significance of complexation in pharmaceutical products, appreciate the fundamental forces that are related to the formation of drug complexes. See, there are several forces are involved in the formation of complexes, like van der Waals forces, hydrogen bonding, then covalent bonding, coordinate bonding, and these are the various several forces that is involved in the complexation of drug complexes. So appreciate the fundamental forces that are related to the formation of drug complexes is also comes under these topics. And also there we know that there are different types of complexes, like molecular complexes, metal complexes, organic molecular complexes, and inclusion complexes. So the differentiate between the types of complexations, there are different types of complexation processes are involved in the formation of various types of complexes. So we are going in detail the what is the mechanism behind the formation of each category of complexes. Next, understand the mechanism of coordinate bond formation leading to the formation of coordinate complexes. And also we are going to study the biological and pharmaceutical role of each category of complexes. How does it affects bioavailability? How does it affects the absorption of the drugs? How does it affects the stability, like solid state stabilities and physical state? So these are all the some of the various applications of the complexes. So their main role in drug delivery and drug therapy is comes under these sections. So the biological and pharmaceutical role of complexes is also comes under these sections. Now another one is the most out of all these classifications, the most important one is the inclusion complexes. Inclusion complexes are also known as occlusion compounds. So they are also known as ghost guest chemistry. So here the one compound will act as a guest molecule, another molecule will act as a ghost molecules. So there may be an interaction between the ghost molecules and the guest molecules, so that we call it as ghost guest chemistry. Okay, so that also will leads to the formation of complexes. It is such a type of complexes are known as inclusion complexes and is also known as occlusion compounds. It is also comes under the principle of ghost guest chemistry. Okay, so mechanism this detail we are going to study in detail the mechanism of inclusion complex formations with special emphasis on drug cyclodextrin complexes. So the cyclodextrin is the complexing agents. It has a tendency to form inclusion complexes or ghost guest chemistry complexes or occlusion compounds with variety of drugs. So there are mainly three types of cyclodextrin: alpha, beta, and gamma cyclodextrins. So each compound has its own capability to form complexes with various drug molecules, and also relate the formation of drug cyclodextrin complexes with improvements in the physical property and bioavailability of the drugs. I already told you that A and B are the individual components. We can assume that A is the drug molecule and B is the complexing agents like cyclodextrins. So once A and B react together to form complex C, the property of complex C will vary from both A and B. Similarly, once it forms a complexes, it may enhance or improve the physicochemical properties of the drugs, and at the same time, it improves the bioavailability of the drugs. So that we call it as the enhancement of physicochemical properties and bioavailability of the drugs. So this is application is widely seen in case of inclusion complexes or occlusion complexes. So next one, determine the values of association constant and stoichiometric associations. See, the complex formation between the components, individual components, say for example A and B, is based on a fixed stoichiometric ratios. Okay, and we are going to analyze the complex formations, that we call it as method of analysis of complex formations. There are different techniques are involved in the analysis of complexes, like pH titration method of analysis of complexes, solubility method of analysis of complexes, distribution method of analysis of complexes, and the Jo's method of continuous variation. So these all techniques will help to analyze the complex formation between the individual components. So we are going to determine the overall stability constant, and also we are going to determine the interaction rate constant. They are also known as the formation constants. So we are going to determine the interaction rate constants and formation constants, and also the overall stability constants. So there are different methods of analysis of complexes are involved in the determination of complexes. Next one, appreciate the significance of protein drug interactions. So there, the protein drug binding is also an example of the example of complex formations. So we know that there are different plasma proteins are involved inside the plasma, like alpha 1 acid glycoprotein, albumin, and globulins. So these are some of the plasma proteins. They are responsible for forming complexes with the drug molecules, that we call it as a protein drug interactions. Okay, so here the drug molecules and protein will act as a complexing agent. So protein and drug react together to form protein drug complexes. Now, how does it affects the ADME? ADME is nothing but absorption, distribution, metabolism, and excretions of drug molecules. Okay, so how does it protein binding affects absorption behavior phenomena, distribution phenomena, metabolism phenomena, and excretion phenomena. And also we are going to study in detail what are the various factors affecting the drug protein binding, whether it is drug related factors, whether it is protein related factors, and other physicochemical properties of this. So that also we are going to study in detail in these sections. And also we are going to study the extent of protein binding. Extent of protein binding can be determined by equilibrium dialysis method and also by dynamic dialysis methods. So these are the in vitro analysis of drug protein binding techniques. Okay, so the dynamic equilibrium dialysis methods and also the dynamic dialysis method of analysis of complexes for finding out extent of the drug protein binding. Also, identify the important properties of plasma proteins and mechanism of their interaction with the drugs. See, I already told you that there are a number of plasma proteins like serum albumin, serum globulins, and alpha 1 acid glycoproteins. These are the plasma proteins responsible for forming complexes with drug molecules. So the properties of plasma proteins are important for forming complexes with the drug molecules, and also their mechanism of their interaction with the drug molecule is also equally important. So the physicochemical properties of the drugs and proteins, and also the affinity of protein towards the drug molecule is also equally important. And we are going, in addition to this, we are going to study in detail the kinetics of protein drug binding. That also we are going to study in detail in these sessions. So this entire topic will give you an idea about the formation of complexes, the different types of complexes, its applications in detail, whether it is a role in its drug delivery, and also in drug therapy. That all we are going to study in detail. And also plasma drug protein binding is one of the important applications of plasma complex formations. So how does it affect the absorption, distribution, metabolism, and excretion of the drugs? And also we are going to study the extent of drug protein binding by the dynamic dialysis methods and also the equilibrium dialysis methods. And finally, we are going to study in the detail the kinetics of drug protein binding. So this is the end of the sessions. Thank you all for your active listening. Thank you all.